Okay, go ahead. Guys, have a seat. I'm taking care of this. No, that's all right, it's my turn.
No.
Okay, please raise your hand if you need a pencil. Raise your hand if you need something, please. Okay, here's the deal. Today, we're done. Okay, here's the deal. Today we're going to start designing our new projects, okay? And that's we have a good half of the class or so that's ready to move on. And I know some of you still have to finish your clipboards, okay? So, what that means is Thursday will be a work day because I don't have you on Wednesday. I don't have you tomorrow, okay?
Halloween.
No, you guys have your Halloween assembly, right? Yeah. Holy.
Oh, I need a pencil. Yeah.
Well, I can get mine from my little Foot Locker down there. So
Okay, hands should be up if you still need a pencil. What questions do you have for me on the timeline of wrapping up these projects? You guys are good. Spray one of those. We're doing design. Okay, so if we cooperate and lecture goes well, we're going to work in partners and listen to music and do some drawing, okay? But if it doesn't go well, we don't get to do that. I just get to lecture all hours. Okay? So, we're going to start with, we're going to talk about what our projects are made of. Okay? And if somebody's really smart, they'll read the board behind me and tell me what we're going to talk about first.
lumber.
Lumber.
Whoa, Brooklyn, why did you say lumber?
It says it right there.
The right answer would have been because that's what we're going to make our projects out of.
Yeah.
Okay, so, lumber. Who knows how we measure lumber? If I ask
In feet. Or
in feet, okay, so Brooklyn said feet. So, Colton wants to build a house, okay? And he goes to Menards and he says, hey Menards lumber guy, I need 8,425 feet of board because I'm building a house. Okay? So the guy from Menards does a few calculations and Colton's house turns out to be about 700 square feet and it'll fit in a shipping container. It's a tiny house. But Mr. Bertucci hit the lotto and he wanted to build a 4,500 square foot mansion with a pole barn and a 4-stall garage and a workshop. But instead he got a shipping container house. Just because he told the Menards guy that that's what he wanted for lumber. And the Menards guy said, no problem, sir, I got you, set you right up. Okay? So we don't measure boards just in feet. So if we took these boards over here, right, and they're inch by 8 inches, and then I take a sticker, and I have an 1 by 10, that's the same length as this. The linear feet would be exactly the same. About 32 inches, so we'd be at what? 3/4 of a foot. Or, excuse me, 3 feet, just over, just under. And then we'd have the same linear feet as that. We cut it at 32 inches, right?
yeah.
So somebody yelled out another way that we could measure lumber. Board feet. Who knows how a board foot is measured?
It's a yard.
Raise your hand. I'm sorry? You have to walk on it? Get your feet? So it's measured with our length, width, and thickness over 144. Somebody raise their hand and ask why it's 144. Brock.
Does that be the area of a 12 by 12 thing?
No. Why is it 144, Mr. Frisbee?
It's good. Brock, what did you just say?
Because it's the area of a 12 by 12 piece of anything.
Good. So it's the inches in a square foot. Okay? So if we have 3 values on top, but only this is a square foot, so we'd have 2 here, we'd end up with feet. We'd end up with 1 value, right? Because we have cubed on top and squared on bottom, so we'd end up with 1 value. That means feet. So you said 12 by 12, right? So 144 for this equation is like pi r squared. Okay? It's like pi. It's a constant. We always use it for that equation. Does that make a little bit of sense?
Yeah.
Why didn't anybody raise their hand and say, but Mr. Frisbee, pi r round, not squared?
Well, it's the number pi.
Oh, it's the number pi.
3.14 repeated.
Wait, isn't that what you used to get diameter?
What's that? Is 3 point, excuse me, is pi r squared diameter or surface area?
Surface area.
2 pi r is
Oh, it's
diameter, right?
diameter. No, it's diameter to the whole Yeah, it's
Yeah, you guys
diameter.
know.
It's
So, at
diameter.
any rate, if we're solving for surface area or diameter of a circle, right, we use pi. That's our constant value. We just always use it. Same when we're calculating board feet. We always use 144. So, if we think back to our mansion that Colton was going to build, and he said, I need 8,000 feet of white pine lumber to build my house. And somebody did it in linear feet as opposed to board feet. What would be the difference in the amount of lumber he had? Would Colton get more lumber if he set his amount, or excuse me, if the guy solved for board feet, or would he get more lumber if he did linear feet?
4 feet.
Linear feet, actually. He would get way more lumber because we wouldn't be dividing by 144, we would just be using the feet. Right?
Yes.
So it's important we know how we calculate before we build our project. Because if he needed 8,000 board feet of lumber, and they gave him 8,000 linear feet of lumber, he'd be able to build, way bigger than his mansion.
We could build 4 of them mansions.
Right. Yes.
What's that?
I'm being videotaped. Just to make sure you guys behave. I
I
need eyes from the back of the classroom.
No, it's just to make the air
That's right. So if y'all want to turn around and wave at the camera, go ahead.
Hello.
There you go. No, it's just so I can evaluate myself. I should have told you that at the beginning. But
It's a lesson for yourself.
lesson for myself, exactly. Okay, so back to it. So if we had, we'll go with our boards over there in the dryer there. There were 1 inch. Oh, excuse me. We got to go length first. So they're approximately 8 feet by 10 inches by 1 inch. Okay? Who knows or can tell me what 8 feet as inches? What is 8 feet in inches? Because we have to represent all these values in inches. 96. Fast. So 8 is our length, 10 is our width, and 1 is our thickness, or height, however you'd like to put that. And 144 is our constant, right? So we have 96 inches times 10 inches times 1 inch. Who's the math whiz in here? Troy?
960 divided by 144.
960 divided by 144. Okay? Our 960 came from our 3 values, right? So,
Wait, where did the 96 come from?
the 96, remember, 8 feet in inches is 96 inches.
Oh, so it's near 50. Alright, I
We
get it.
just converted it, yep. So 6 and 2/3. So we would have roughly 6 and 2/3 board feet.
Why don't you just round it to 7?
You could round it up, yep. But if somebody rounded up while Colton was buying lumber for his, if Colton was buying lumber for his mansion, and they rounded up, he could easily be shorted, right? If we rounded 6 and 2/3 up to 7. The only time when we're calculating board feet, the only time we calculate board feet is when we round is the thickness. Okay? So if those boards were only half an inch, they are still a value of 1 inch. So when is the only time we round up?
Then it's like the
When the
thickness.
thickness is less than 1 inch. We calculate it as 1 inch. Even if it's half-inch lumber. Okay? So, Brooklyn told us we're making our projects out of wood, right?
Yeah.
Now we know how to calculate board feet. Okay? What questions do you have for me about calculating board feet? Brooklyn,
Are we gonna do this about projects next time or we'll do
bingo. Brooklyn's on top of his game today. I love it. Okay? So, before Colton knew that he was going to buy his lumber at Menards, how did he have any idea how much lumber he was going to need? Did he just go up to Menards and say, I needed 8,240 feet of lumber?
I guess so.
Board feet of lumber, because we just figured that, right? What did he have to do? What'd you say? Draw a sketch. Did you read that off the board, or did you know that one? You knew it, didn't you?
It says shop sketch.
A shop sketch. So we'll start with a shop sketch. Do you remember when we were drawing our clipboards? I asked you to draw roughly the shape that we wanted on there. Do you remember that, or no?
Yeah.
Remember I told you you had to take the piece of paper and visualize it as your clipboard? And we had to make that into roughly how we wanted it to look. Okay? That's essentially the purpose of a shop sketch. Okay? So we can begin to add dimensions. We can begin to add the types of wood we would like to use and label those things out so we can properly estimate what we'll need for lumber, right? Because if you come up to me when we get ready to go in the shop for our projects and say, Mr. Frisbee, I need 4 boards because I need 4 of those 1x8 boards because I have 4 boards on my shelf.
You could use like half a board for that.
Probably even less than that, right?
Yeah.
Do we think we need 4 of those 8-foot 1x8 boards
No.
to make this shelf?
Yes.
I'm sure you all could find a way to use those boards to make one shelf, but I'm just kidding. You all know how to use material properly, right?
We kind of did chunk out it right in the middle and just leave
So realistically, we could probably use one even smaller than half the size of our desk, right? We could probably make it out of about 2 clipboards. Size of board. Okay? So we need to find out how our project's going to be set up and what material we're going to use so we can calculate how much material we're going to end up using, right? So how much and what kind to calculate it. So, who remembers a little bit of anything about 3-view drawings?
They have 3 views. Side, back, and front.
Boom. It's got 3 views. Got that part out of the way.
3D.
Nope, 3 views not necessarily 3D. So I've got this little prop here. I made it. It took me a long time to make this prop.
When you take it apart,
Side,
Okay?
front.
this is the stairs.
Did it with the stairs.
Yeah, we went to
Over here, this that one? You took those apart?
No,
Okay, so I've got this prop. It took me about 2 hours last night to build this thing. Wow. A little rough. Okay, so Bobby, will you read that word on the front? Does it say that?
Yeah.
Okay. So that is what we would see if we drew this box in a front view. Who remembers what three views are in a front or in a three-view drawing? Who remembers?
Side, top, and bottom.
You said front, right side. You got those two.
And the top.
Who read the box? Okay. So we've got our front, top, and right side. No, just listen for me. Recollect, okay? So, front. How is this going to look when I draw the front view? What's it going to look like? Something like that, right? Why not? I have to trim my tails? It's going to be perfectly square, but my drawing's not?
Yes.
What would be different in the front view?
Would you need to like, that has like the side, you can actually see it?
Nope,
Maybe put it
not
on
in,
top.
not in a three view. That'll be the next one we talk about. But you're on the right track. You aren't wrong. But in a three view, we only represent what we see. So now, if I were to show you the right side, what would we see?
The exact same thing. But you get a little bit of the back view.
Nope, sorry, I didn't mean to pull that apart. What would we see?
The exact same thing.
How about the top? Who can guess?
The exact same thing.
Right? It's a cube. So we're going to see the exact same thing, right?
Repeat.
It's like 6 2/3. We calculate the board feet. Just keeps repeating. Just kidding. Not like that. Okay? So we have our front, top, and our right side. If Mr. Frisbee was really good at drawing, he would have made these match up, and these match up. That one's really bad. I can't even lie about that one. And these would match up. Okay? So when we draw our front view, the lines carry over to our right side and our top. So if our block had a hole through the center, who knows how I would represent that hole? Can they remember from last year? For Transstack, Troy?
Wouldn't there be like the dotted line going through the middle of the right side?
Very good. Those are what we call hidden lines. So those go up through. And what do we remember about our features in the top and the front view in relation to these?
They rotate 90 degrees.
They share with each other, right? They do rotate. But I'll draw it in a different color because this wouldn't be on our drawing. But see? The outside of that hole matches with that. And then our right side will look something like this, right? Okay? Because then our features over here, we share lines, right? So what's the first thing about a three-view drawing? How many drawings are there? 3. How many, what do we know about the lines?
Dotted.
No, that's hidden lines, remember?
Straight.
So if we had a hole through it, they're straight, and what are they in relation to each other? They match up, right? That's kind of a vague question that I just asked you, so it didn't really make sense. But we know a three view has 3 views, and then our lines share properties, right? So these lines match up, and these lines match up. Okay? So, if you agree with this statement, raise your hand. If you disagree, keep it down. I could draw this cube with 2 views and have an accurate amount of dimensions. So I could draw this cube with 2 views and have all the dimensions I need to build it. If you agree, raise your hand. If you disagree, put it down. Rock, you're the only one that agrees with me.
Yep.
Why do you agree?
Because they're all equal sides.
Okay. So if we specified that they were all equal, I could draw it with 2 views. Okay. Mr. Rader, why did you disagree with me?
Because we need to see the top, the front, and the right side.
Because you need to see all 3 views for it to be a 3-view drawing. That's very logical thinking. That's good. Troy?
Because if the right side isn't included, for all we know, it could be just an empty space.
Okay,
We don't
good.
know
But
what
the
the-
cool thing about this drawing is the top, we know that it now extends back. Okay? So therefore, we would know this is the same side in the right view, right? Right side in the front. So the front's down here and the right side's over here.
Slide in.
Yeah. So there are some shapes that we can use two views and we don't have to use all three. Okay? So another option we can draw, if I were to draw my same box without the hole, is we can draw an isometric drawing. Does anybody remember what the isometric drawing is? Very good, it's 3D. But the cool thing about isometric is all of our horizontal lines are on 30-degree angles, which if you keep that in mind, it'll make your shape 3D for you. Okay, so if I were to draw this box isometric, I'd have the line here, the line here, then I would go up, over, up. Does that make a little bit of sense? What questions do you have for me about isometric? That was a tough concept. Nick,
Can you draw the picture?
can you be a better artist?
Yeah.
That's tough. Okay? So, this is our cube. A really, really bad cube. Okay? So, this line right here would be this one. Can everybody see that?
Yeah.
And our front here is right here. So, in reality, if I flip it like this is our right side, our front, and our top.
You can draw in one view.
Can everybody see that? So if this, we come out here,
See something.
and our top, does that make sense?
Yeah.
Now if we see it as a cube, and then we have our 3D drawing. Let me get these markers out of my hand, hang on. So our 3D drawing's over here. Top, front, right side, right?